Hey guys, you're welcome to Newton Labs Technology. So, in today's class, we will be talking about series and parallel connection. In this class, we will open your eye to the full understanding of what parallel and series connection truly means in general and in electronic circuit designing. There are two basic contexts of parallel and series events generally. Namely, we have the context of direction and we have the context of transfer of energy. But in this class, we are going to be looking at the context in transfer of energy in an electronic circuit. First, what is parallel and series connection in this context? It's simply when two objects, A and B, have a direct effect on the third object, C, without having to pass through each of them. Using mathematical expression, let's consider three objects, A, B, and then C. A and B are the objects with the energy, and C is the object which the energy from these two, from A and B, must act on or create an effect on. Now, the process whereby A has a direct transfer of energy to C and B has a direct transfer of energy to C. This particular expression is known as parallel connection in an electronic circuit. Let's move to an actual battery and see what this means. In an actual battery, which is battery A, if we say that these two batteries are in parallel to this load, which is C, it simply means that the direction at which energy flows out of these two batteries is directly to the load. So for the two batteries, both batteries A and B have a direct transfer of energy to the load. That is where parallel connection is being established in a circuit. So in other words, both batteries are in parallel, and at the same time, both batteries are in parallel to the load. Okay, let's carefully break down the effects that occurs whenever systems are in parallel using a battery. Now, when both batteries are in parallel to a particular load, one of the most significant things that happens is that the energy consumption of the load is being split or divided across the two batteries. So, if the energy consumption of the load is 20 watts, both battery will take 10 watts. So battery A will give out 10 watts and battery B will give out 10 watts. In this case, parallel connection has been established. Now, what is another beauty of parallel connection is this. The energy of one battery is not dependent of the energy of the second battery. So therefore, if battery A gets bad or grow weaker with time, and battery B does not grow weaker with time, battery B will still give out the full supply to the load while battery A is dying. The next definition will be on series connection. In series connection of an object, energy of one object is being transferred through a second object to the load. Example, let's say we have battery A. Let's say we have battery A and battery B. The moment at which series connection is being established in this circuit is when energy is being transferred from battery A through battery B before it gets to the load. So in this case, if you observe something, you see that the positive terminal of the first battery, so you see that the positive terminal of the first battery is connected to the negative terminal of the second battery. That's the positive terminal of battery A is connected to the negative terminal of battery B, which in turn, the negative terminal of battery A and the positive terminal of battery B is now considered as the output that will now feed the load. That will now feed the load. In this case, the energy conserved in battery A is now running through battery B. Now, what are the effects? What are the effects in this kind of connection? The effect is that the total energy of battery A will now be subjected to the total energy that battery B can give out. So what does that mean? If battery B runs down with time in capacity, irrespective of the capacity of battery A, the total system will always run low when battery B is low. So the total capacity of one battery becomes the total capacity of the other battery. Okay, now let's look at the advantages and disadvantages of parallel and series connection. So in parallel connection, though the energy of one battery is independent of the energy of the other batteries, but more heavier terminals are always required because in parallel connection you have higher currents flow or flowing through the circuit than a lower voltage. So because of this, you require heavier terminals to be able to carry that amount of current through your circuit. But in terms of a series connection, you end up having at least minimum currents flowing through your circuit but a higher voltage. Since in general, voltage can be conducted through tiny conductors. You do not need heavier cables or heavier conductors to carry your volts, but you need heavier conductors to carry your currents.